Example 12.7 Compressive stress in a pillar. So based on the given problem, our given is R, the weight of the sculpture, which is 10,000 Newton, the height is 3 meter, and the cross-sectional area with 0.20 meters squared, and the mass density with 2,700 kilogram per meter cube, and our modulus, young modulus of granite is equal to 4.5 times 10 raised to 10 Pascal, or 4.5 times 10 raised to 7 kilopascal. So what are we trying to find is the compressive stress and the compressive strain. So solution. So first we need to find the volume of the pillar segment. So we're going to use the height and the cross-sectional area, since volume is equals to area times height. So the value of the area is equals to 0.20 meter squared times the height 3 meters is equal to, the volume is equal to 0.60 meter cube. And now let's find the mass of the pillar segment. So mass is equal to the density times the volume. So substitution of the value. So the value of the density is equal to 2,700 kilogram meter cube, or 2.7 times 10 raised to 3 kilogram meter per cube, times the volume 0.60 meter cube. So the mass of the pillar segment is equals to 1.60 times 10 raised to 3 kilogram. And now let's solve for the weight of the pillar segment. So weight of the pillar segment is equals to the mass times the gravity. So mass is equal to 1.60 times 10 raised to 3 kilogram times gravity 9.80 meter per second squared. So the mass of the weight of the pillar segment is equal to 1.568 times 10 raised to 4 Newton. And now based on the given problem, the weight of the sculpture again is equals to 10,000 Newton. So let's find the deforming force, or the force is equals to the weight of the pillar segment plus the weight of the sculpture. So 1.568 plus 1.0 times 10 raised to 4 Newton. So the force is equals to 2.568 times 10 raised to 4 Newton. Therefore, the stress, which is equal to the force over the area, is equals to 2.568 times 10 raised to 4 Newton over 0.20 meter squared is equals to 1.284 times 10 raised to 5, or the stress, the compressive stress is equals to 128.4 kilopascal. And for the compressive strain, so stress is equals to strain is equals to stress over the young modulus of granite. So it is equal to 128.4 kilopascal divided by 4.5 times 10 raised to 7 kilopascal is equals to 2.85 times 10 raised to negative 6. Example 12.8 Stretching a rod. So based on the given problem, our given are the mass of the platform, which is 550 kilogram, the cross-sectional area with 0.30 cm squared, and the original length, which is 2.0 meter, and the young modulus of steel, which is equals to 2.0 times 10 raised to 11 Pascal. So what are we trying to find here is the tensile stress and the elongation of rod under stress. So solution. So first we're going to compute for the tensile stress in the rod under the weight of the platform. So using the equation 12.34, which is 10 stress is equals to the deforming force over the cross-sectional area. So substitution, so the deforming force is equals to the mass times the gravity. So mass is equals to 550 kilogram times the gravity, which is 9.8 meter per second squared, divided by the sectional area, which is 3.0 times 10 raised to 5 meters squared. So our tensile stress is equals to 1.8 times 10 raised to 8 Pascal. So now let's solve for the elongation of the rod under stress. So we're going to find the rod's elongation using the original length is equals to 2.0 meter. Now change of length is equals to the um, force divide over area times original length times Young modulus of steel. So we all know that the force over area or the tensile stress is equals to 1.8 times 10 raised to 8 Pascal. Then the value of the original length is 2.0 meter times the value of the Young modulus of steel, which is 2.0 times 10 raised to 11 Pascal. So our change change in length is equals to 1.8 times 10 raised to negative 3 meter or 1.8 mm. Example 12.9, hydraulic press. So based on the given problem, our given are the original volume, which is 250 liters, increase in pressure is equals to 2300 psi, and our compressibility is equals to compressibility of oil, which is 2.0 times 10 raised to negative 5 per atmosphere. So what are we trying to find here is the bulk strain and the change in volume. So solution. So first we're going to convert the pressure increase from PSA to atmosphere. So the increase in pressure is equals to 2300 psi is equals to 2300 divided by 14.7 atmosphere, approximately equal to 160 atmosphere. So now we're going to use the equation 12.40, but we're going to manipulate it, so we're going to arrive in this equation. So bulk strain is equals to change in volume over original volume is equals to increase in pressure times the bulk modulus, and the final is the compressibility times the increase in pressure. So substitute the value, so compressibility is equals to 2.0 times 10 raised to negative 5 over atmosphere times the increase in pressure, which is 160 atmosphere. So our bulk strain is equals to 0.0032. Now so let's solve for the change in volume. So 0.032, and our original volume is equals to 2.50, so we're going to multiply the 0.0032 to the 250 liters. So our change in volume is equals to 0.78 liters. Example 12.10, an old bookshelf. So based on the given problem, our given are the force or the parallel force is equals to 15 Newton. The gradual shift is equals to 15 centimeter. Our original length is equals to 1.80 centimeter, and our area is equals to 2700 cm squared. So we're going to multiply the 30 meters deep and the 90 meters wide of the shelf. So our area is equals to 2700 cm squared. So here we're going to find the shear modulus. So shear modulus, solution. So shear modulus is equals to the parallel force over the area times the original length over gradual shift. So as you can see, lahat ng kailangan para ma-solve yung shear modulus is given. So let's substitute the value. So our parallel force is equals to 15 Newton over area with 2,700 cm squared times the original length, which is 180 cm, and over the gradual shift with 15 cm. So it's equals to 2 over 9 Newton over cm squared. So 2 over 9 times 10 raised to 4 Newton meter squared is equals to 20 over 9 times 10 raised to 3 Pascal. So overall, the answer is 2.222 kilopascal. So we can also solve it. We can also solve it or find the shear stress and strain respectively. So first, we're going to solve the shear stress, which is the parallel force over area. 50 Newton times 2,700 cm is equals to 5 over 27. So the answer is 185.2 Pascal. For shear strain, gradual shift divided by original length is equals to 15 centimeter over 180 centimeters is equals to 1 over 12. So shear strain is equals to 0.083. Example 15.2, determining the equation of motion for block and the spring. So based on the given problem, so our x or a is equals to positive 0.02 meters and the time is equals to 1.57 seconds, and our phase shift is 0 because the block is released from rest. So we're going to find the equation of motion. So solution. So first, we're going to solve first the angular frequency. So in order for us to solve also or to determine the maximum velocity and the maximum acceleration. So we all know that the angular frequency is equals to 2 pi over time. So angular frequency is equals to 2 pi over the time, which is 1.57 seconds. So the answer would be 4.00 seconds raised to negative 1. So in order to solve this using the calculator, we're going to put the calculator into radian mode. So now we have the value of our angular frequency. We can solve now for the maximum velocity. So maximum velocity is equals to the amplitude times the angular frequency. So 0.02 meters times 4 is equals to 0.08 meter per second. And now for the maximum acceleration, so amplitude times the angular frequency squared. So 0.02 meters times 4 squared is equals to 0.32 meter per second squared. And now, since we have the value of the angular frequency, maximum velocity, and the maximum acceleration, we can now have the equation of motion. So first, for the x as a function of time is equals to amplitude, or multiply the cosine function to the amplitude times the angular frequency times time plus the phase shift. So it's equals to first the value of the amplitude, which is 0.02 meters times cosine times the value of the angular frequency, which is 4 seconds raised to negative 1 times time plus, since the value of shift is 0, so kana ra na siya. Now velocity as a function of time is equals to negative maximum velocity times sin times angular frequency times time plus phase shift. So negative 0.08 meter per second times sine times 4 seconds raised to negative 1 times time. So next, acceleration as a function of time is equals to negative maximum acceleration times cosine times angular frequency times time plus phase shift is equals to negative 0.32 meter per second squared times cosine times 4 seconds raised to negative 1 times time.